Hello everyone, welcome to this video. In this video I'm going to show you an application of the Pythagorean Theorem in a sort of question that relates to real life. So let me give you an example of what that would look like. So let's say we have Johnny, and Johnny is biking back from school to home. This is his path. If he bikes at a constant speed, meaning his speed is not changing, at a constant speed of, let's say, 6 kilometers per hour, how long until he reaches home? So now I have to show you what that would look like. It would be like this. So I would have my, let's say I draw here is a school. Let's say a school. Here we have our little windows. Okay, we have our little education symbols. Okay, so this is school here. Okay, not a great image of the school, but I'm not an artist. Okay, then from here, he wants to reach home, which is over here. See, this is let me just draw a little window, a little door. Okay, so this is Johnny's house, and okay, he has a little porch. All right, I think that's enough. So let's say I'm given the direct. So let's say we have here all straight directly home, all over the buildings and roads between them. This distance is, let's say, 7 kilometers. And this is the road that he is traveling on. Let me change up the color to show you that it's something else. So here we have our little road. This is the road that he's traveling on. So Johnny here, he can't just go through everything. He has to travel on the road. So he goes like this. And then he travels like this. Okay. And, oops. So he travels like this. And then he travels like this. Just want to make it straight. Okay. And then we know that this is a right angle. Okay. Now, even though this is a little hard to see, we know that we have this right angle here and we have these three sides, meaning it forms a right angle triangle. And let's say here there's a really famous tree. So here there's a big tree. So tree is 1 point, the school is 1 point, and then his home is 1 point. So as Johnny is biking back, he wants to know how long it's going to take, or you want to know how long it's going to take. So we know that this side is 7 kilometers, and then they say the distance between the house and the tree is, let's say, 6 kilometers. So now we got the side of this side's length, 6 kilometers. All we have to do is then find this side and then calculate his the amount of time he took. So let's do that. So here, this is the longest side, right? This is the diagonal one, and it's opposite to the right angle, meaning that this side is going to be in place of the c. So we put it as here 7 squared is equal to, and then we put 6 squared as in the a, And then here we have the unknown. Let's put it as x plus x squared. So then to solve for this, I have to put this on this side. It'll be x squared is equal to 7 squared minus 6 squared. X squared is equal to 49 minus 36. And then what is 49? 49 minus 36. It's 13. And therefore x is equal to the square root of 13. So here, in place of x, we'll put the square root of 13 kilometers. Okay, now what is the square root of 13? The square root of 13 is around 3.6, somewhere around 3.6 kilometers. But to keep things exact, I'm going to keep it in this form. Okay, the main question that they're asking isn't necessarily what the distance is between the school and the tree. It's actually how long it's going to take when he's traveling a certain speed. And since he is going at 6 kilometers per hour, and he is traveling, how much is he traveling? He's traveling the square root of 13 plus 6 kilometers. So let's do that. The square root of 13 plus 6. Okay, I'll just round for this one just to make life easier, and I'll put it as 9.6 kilometers. So if he travels 9.6 kilometers at a speed of 6 kilometers per hour, how long is he going to take? All right. So what we have to do here is divide 6 by 9.6. So 6 divided by 9.6 gives us, oh wait a minute, no. Let me show you exactly what I mean by this. We do 6 kilometers per hour, and we have 9.6 kilometers. So we have to be taking 6 kilometers out of the 9.6. All we have to do is 9.6 divided by 6, and that leaves us with 1.6 hours. So how long is it going to take for Johnny to get back if he's traveling at a speed of 6 kilometers per hour and he's traveling 9.6 kilometers? He's going to be traveling for 1.6 hours. All right, so we kind of went a little overboard here. We went a little ahead of ourselves, a little advanced, but I hope you were able to follow along. In the future videos, I'll make sure to go into a lot more detail on every single step that I did so far, and some future applications of trigonometry, as well as some more physics. But for the time being, I'm going to include this video in a playlist that includes everything you need to know in terms of trigonometry for all levels of education, from grade 4 all the way until first year university. So stay tuned, and I'll see you in the next one.